Hello everyone, I am Pubali Mondol. I am one of the teaching assistants of this life cycle analysis course. I welcome you all to the tutorial session of this life cycle analysis course. So here we will discuss about few problems. We will solve basically a few problems based on IPAT equations and some hazard and risk analysis problems. So IPAT equation is basically used for measuring. It is an equation which is used for assessing the magnitude of sustainability challenges that our societies are facing, like in terms of energy uses or material uses or some other environmental emissions. So coming to our first numerical problems. So IPAT equation is basically I is equal to P into A into T. So here P is equal to our population, A is our affluences, which is basically gross domestic product divided by the number of people in that region, and our T is technology, which is used for delivering our affluences. So coming to our first problem, here what we have to do is we have to calculate our impact in 2060 relative to 2010, and our given data is, it is given that population growth is 1% per year. So this is basically our nothing but P, and global economic activity per person grows 2% per year. So this is our affluences, and energy consumption per dollar of GDP grows 1% per year. So this is our T. So now we have to calculate our I. So I is equal to P into A into T. So P will be 1 by 1 plus 100 to the power, as we know that our number of years is 2060 minus 2010. So it will be 50 years. So this will be to the power 50 into 1 plus 2 by 100 to the power 50 into 1 plus 1 by 100 to the power 50. So this, if you will calculate, it will be 7.28%. Now, so if we will consider that this is our I1 and our I2, in the second case it is given that how much does this estimate change if the population growth is 2%. So now our P changes from 1% to 2% per year, and our economic growth is 3%. So our affluences changes 3% per year, and economic consumption per dollar of GDP grows, which is our T, it become 2% per year. So now our I2 will be P into A into T. So it will be 1 plus 2 by 100 to the power 50, 1 plus 3 by 100 to the power 50 into 1 plus 2 by 100 to the power 50. So if you will calculate this, it will be 31.76%. Now it has been asked that what is the percentage increase or decrease due to the changes in population, affluences and technologies. So we can calculate percentage increase is equal to 31.76 minus 7.28%. So it will become 24.48%. So this is our answer of the final. Now coming to our second numerical problem, which is actually on risk analysis. So it has been said that 10,000 persons lose their lives in vehicular accidents in a state of population 100 million. So here the death number is 10,000, which is nothing but our risk, and we know that risk is our population multiplied by our exposure time multiplied by hazard. So in this case, the population has been given. So population is 100 million. and exposure time is also given, it is 1 year. So we can calculate our hazard because risk is already given. So our hazard will be our risk, which is 10,000 divided by our population, which is 100 into 10 to the power 6, exposure time is 1 year. So our hazard, if you calculate, then your hazard will be 10 to the power 4 death minus 4 death per people per year. So once we will get our hazard, this one, then we can calculate the risk, which is asking in that question that how many fatalities would be expected over a 2-day weekend in a city of that state which has a population of 5 million. So now we can calculate risk because we know our hazard. So our population is 5 million. So it will be 5 into 10 to the power 6. Now one thing we must remember that this exposure time is must be in year. So we have to calculate our 2-day in year. So it will be 2 by 365 into our hazard that we have already calculated this one. So 10 to the power minus 4. So if you will calculate, this will become 2.74 deaths. So this is our final answer which has been asked. So we will go to our third numerical problem. So here it has been asked that a fluorescent bulb has been used and one incandescent bulb has been used. So in case of fluorescent bulb, if we are using incandescent bulb and if we are using it for 1000 hour of life, then how much additional electricity will be required if we are using incandescent bulb in place of instead of fluorescent bulb. So the for fluorescent bulb, it is 5 watt, and for incandescent bulb this one is 25 watt. So additional requirement is our 25 minus 5. So this will be our 20 watt. Now what we have to do is we have to calculate our electricity requirement. So our additional electricity requirement is our 20 watt in for 1000 hour divided by 1000 because we want to convert it to kilowatt hour. So it will become 20 kilowatt hour. Now it has been said in this problem that our transmission losses are 15% and our electricity generation efficiency is 40%. So now we have to consider our transmission losses and electricity generation, and we have to again calculate our additional electricity requirement. So that will be much bigger than that what now we are calculating, it is 20 kilowatt hour. So considering transmission losses of 15% and electricity generation of 40%. So this will become 20 divided by 1 minus 0.15 into 0.40. So if you will calculate this, it will be 58.82 kilowatt hour. Now in the second part of the question paper, it has been said that how much amount of coal is required if the heat of combustion of coal is 8 kilowatt hour per kg. So now from this data we need to calculate the amount of coal which we require for generating this much amount of electricity. So the amount of coal required (58.82 kilowatt hour) divided by, it has been given that heat of combustion of coal is 8 kilowatt hour per kg. So our final coal requirement is 7.35 kg for generating 58.82 kilowatt hour of electricity. So, this is our final answer of our third numerical problem. Coming to our fourth numerical problem, this is one kind of similar problem, but it is slightly deviated from the previous problem. So, here also in Dallas area it has been said that an Dallas area coal supply is from PRB. So, we have to calculate again the coal requirement to support the consumers in dollar. So, what is the requirement of Dallas? So, requirement of electricity in Dallas area is 3 billion kilowatt hour per year. So, we have to calculate the amount of coal required for generating this much amount of electricity. So, the amount of coal required is 3 billion kilowatt hour we have to generate in 1 year time, and it has been said that 1 kilowatt hour is equal to 3412 BTU. So, we will convert it into BTU, which is British thermal unit. So, multiplied by, it has been also said that the heat content of the coal is 7500 BTU per pound. So, it will be 1 pound by 7500 BTU, and it has also been said that the average conversion efficiency is 19%. So, we have to also incorporate this. So, we will divide this whole by 0.19. So, it will become, if you will calculate this, it will come 7.18 billion pound or 3.25 million tons. Now, what we have to do in the second part of our problem, it has been said that if the energy required to transport this coal by train is 0.003 gallons per ton mile and the distance is 100 mile, then what fraction of the total energy consumption is due to transport? So, now we are transporting our coal by train. So, how much energy will be required for in this transporting portion? So, energy required for transporting coal will be 3.25 million ton, because we need this much amount of coal we have to transport, and 0.003 gallon per ton mile is our energy required for transporting the coal. So, we have to multiply this by 124,000 BTU per gallon, because this is the energy requirement. So, assume that diesel fuel has an energy content of this much. So, this is the energy content of diesel fuel multiplied by our mile. So, if you will calculate this, you will get 120.9 billion BTU. Now, what has been said that, so requirement is electricity is 3 billion kilowatt hour per year. So, amount of coal required we have calculated, and energy required for transporting the coal is 120.9 billion BTU. Now, what percent of this transport, for this transportation, what percent of energy requirement is the total, out of the total energy consumption, what is required for this transportation? So, percentage requirement for transportation of coal will be 120.9 billion ton BTU divided by our total consumption into 100. So, for our total consumption, we need to calculate our energy consumption for generating electricity. So, energy consumption will be in the first case, so it will be 3 billion kilowatt hour into 3412 BTU per kilowatt hour divided by 0.19, which is our energy conversion efficiency. So this will, if you will calculate, you will get 53873.6 billion BTU. Now if we are getting this, we have this, and we have 120.9 billion BTU for transportation of coal. So we can calculate the percentage requirement for transportation. So this will be our 120.9 billion BTU divided by 120.9 plus this one 6 billion BTU, which will be into 100. So this will be 0.22 percentage. So practicing, I am suggesting you this book. You can solve the exercises for your examination. The book name is Sustainable Engineering. It is written by David T. Allen and David R. Schonard. So all the best for your future examination, and thank you.